Everyone, welcome back. This is part two of the statistics refresher module that I created on my YouTube, which will help you prepare for CFA level 1 quant. So we're going to talk about four new questions today. So let's get started. An analyst estimates the following probability distribution for a stock's return. There's three different states of the economy that are provided, probability and the return, and we are required to calculate the standard deviation of returns. So before we do that, we need to calculate the expected return, right? So to calculate the expected return, the formula that we're going to use is simply the summation of mu is simply the summation of the probability times the return. So we're going to do 0.2 times minus 5% plus 0.5 times 8% plus 0.3 times 15%. Once you solve for this, you should get your answer as 7.5%. So that's our mu, or the expected return. The next thing we need to do is calculate the variance. So to calculate variance, we're going to use this formula, which was covered in my last video as well, which is Ri minus mu, or the expected return, squared. So let's look at all of our returns. These are all our return series data. Okay, so minus 5 minus 7.5 square, okay, multiplied with the probability associated with it, which is 0.2. And we are going to proceed in a similar fashion where we're going to do next is 8 minus 7.5 square multiplied with the probability associated with 0.5. And the last one would be 15 minus 7.5 square multiplied by the probability associated with it, which is 0.3. Okay. Next step would be for you to solve for all this. So I've already solved this. It should be 31.25. This should be 0.125, and this should be 16.875. The next thing that we need to do is add all these up. So if you add all this up, you will get 48.25, and this should be like percent square. Be careful that this is variance. What we need to calculate is the standard deviation. So to calculate the standard deviation, we're going to take the under root of this number, 48.25, and the answer would be 6.95 squared. Okay, this is how we solve the question for calculating the standard deviation when we are given probabilities. Okay, so the closest answer is A, which is correct. Now let's go to the second question. Two portfolios have the following characteristics. There's portfolio A and B with the expected return and standard deviation. Which portfolio has lower risk per unit of return? A lower risk per unit of return. So for this, we would use what we call the formula, or without the formula even, like what it basically means is we need to find the coefficient of variation. Coefficient of variation, the formula is simply this, standard deviation divided by mu. This provides us a measure of risk per unit of return. Provides us a measure of risk per unit of return. So for portfolio A and B, we're going to calculate the coefficient of variation. So coefficient of variation of A is going to be 18% divided by 12%, which is going to be 1.50. Coefficient of variation of B is going to be 12% divided by 9%, which is going to be 1.33. Okay, we can clearly see that the coefficient of variation of A is greater than B. Okay, so which portfolio has lower risk per unit of return? It's going to be B. So the lower the better. Coefficient of variation, the lower the better. Okay, so pretty simple, straightforward, but this is a key idea that is covered in a lot of examinations. The next question we're going to talk about is the Sharpe ratio. Okay, the next question is Sharpe ratio. What is Sharpe ratio? Sharpe ratio is a measure of risk-adjusted return, which is calculated as the excess over the risk-free rate divided by the portfolio's standard deviation. So to put in the formula, Sharpe ratio is simply the return on the portfolio minus the risk-free rate divided by the standard deviation of the portfolio. So RP minus RF is given to us as 14 minus 4, which is 10%. Standard deviation of the portfolio is given to us as 20%. So what would be the Sharpe ratio? The Sharpe ratio would simply be 10% divided by 20%, which is going to be 0.50, which is going to be B. Okay, again, Sharpe ratio is a measure of risk-adjusted return calculated as the excess over the risk-free rate divided by the portfolio's standard deviation. Okay, again, a very common topic covered in a lot of exams. The last question we're going to do today is using what we call the Bayes formula. An analyst uses a quantitative model to predict whether a stock will outperform the market next year. Historical data shows 30% of stocks outperform the market. If a stock will outperform, the model predicts outperform 70% of the time. If the stock will not outperform, the model incorrectly predicts outperform 20% of the time. If the model predicts outperform, what is the probability that the stock will actually outperform? Okay, so pretty confusing, but let's go step by step. But before we proceed, we need to know what the Bayes formula is. The Bayes formula is a rule used to update the probability of an event using new information. So once we get new information, we get updated probabilities. So I'm going to define certain events here. I'm going to say that O is stock outperforms. Okay. And I'm going to say S is that the model signals outperform. Okay. O, stock outperforms. S is that the model signals that it will outperform. So let's look at the probabilities. 30% of stocks outperform the market. So let's say the probability of outperform is 0.30. Probability, like if it outperforms 30% of the time, it naturally means that it does not outperform 70% of the time. So probability of not O is going to be 0.70. If a stock will outperform, like before I write that, P A given B is the probability of A given B. PA given B is probability of A given B. So if a stock will outperform, so we're saying that it's going to outperform, okay, the model predicts outperform 70% of the time. Predicts model signals outperform. So PS given O is going to be 0.7. If a stock will not outperform, so we're saying now that the stock is not going to outperform, not O, we're saying the model predicts outperform 20% of the time. So S is going to be 0.2. So probability of S given not O is 0.2. So we got all the probabilities here. Okay, and the next step for us is going to be calculating the total probability of the signal. The total probability of signal which here we will use the total probability rule. So in this scenario, the total probability will be applied. Probability of signal is probability of the signal multiplied by, oh sorry, probability of signal given outperform multiplied by the probability of outperform plus probability of signal given not O multiplied by probability of not O. Okay, this is the formula that we will be using. So we already have all the variables. Okay, so this would be, this is 0.7 multiplied by 0.3 plus 0.2 multiplied by 0.7. Okay, so we're now going to add this up. So you can see that that's 0.21 plus 0.14, simply that's 0.35. Now, again, I'm going to write the base formula in a general sense. Probability of A given B is probability of B given A multiplied by probability of A divided by, sorry, multiplied by probability of A given B is B given A. Okay, that's true. Divided by probability of B. Okay, in this sense, we got 0.35 as the probability of X. So here, what is the question asking? The question is asking if the model predicts outperform. We're saying if the model predicts outperform, what is the probability that the stock will actually outperform? If the model predicts outperform, what is the probability the stock will actually outperform? So this is basically what we're trying to find. This is what we're trying to find. And if I put it in this format, this would be P S given O multiplied by probability of O divided by probability of S. Okay, so here now I'm gonna just like put the answer here. S given O is 0.7. This is 0.3. Then this is going to be 0.35. Okay, that's what I believe would be the way that we'll solve this answer. 0.7 to 0.3 divided by 0.35. So this is going to be 0.21 divided by 0.35, which is equal to 0.6 or 60%. Okay, so the answer would be B, 60%. So just a refresher, what we did is first we assigned probabilities by looking at the data, right? Then we use the total probability of the signal to find the probability of S, which goes in the denominator of our base formula. And then we simply did the arithmetic to find what the updated probability would be, given that we know that the model will outperform. So these are four very crucial and basic questions that will be covered in the examination. So if you wish to see more questions like this, which I'll be updating in my upcoming videos, please subscribe to my channel. Thank you and have a nice day.